I'm going to go over medians and centroids. A median is a segment that goes from the endpoint, from the midpoint to the vertex. So a segment, meaning this is my median, with endpoints I don't know what I'm spelling. I'm sorry. Oh, dear Lord. Okay. Endpoints. There we go. At the vertex. So it goes from the vertex here and the midpoint. So this is my midpoint. We know that because these are equidistant of the opposite side. And where all of the medians cross, that is the point of concurrency. It is called a centroid. So the point, which is right here, of concurrency of the medians. All right, so this one does have a special circumstance. So so these segments are not equal to each other, but they have the same fraction of the whole. And that'll make more sense in a minute. So point P is 2/3 the distance of the segment from the vertex. So in other words, the part of the segment that goes from the point to the pointy end. So all of these here, that one, this one, and this one, they are not equal to each other. They are 2/3 the distance of that entire line. So of this entire line BL, that pink part is 2/3 of that distance. So that's the way all of those work. And then we still have the other part. So point P is 1/3. So all of these are 1/3. If the others are 2/3, they'd have to be 1/3. And remember, they are not equal to each other. They are just 1/3 of the whole. Is 1/3 the distance of the segment then the side from the sides. And don't forget, medians are at the midpoint. So all of these around the edges, those segments are congruent to each other because it's a midpoint, okay? All right, so this says BE, which is this entire length, is 9. So BQ, which is right here, would be 2/3. And then QE, right here, would be 1/3. So I'm gonna do QE first because that's easier math. If it's 1/3, it's 9 divided by 3, which means QE is 3. And then the way that those two segments are equal to each other is BQ, this piece right here, is gonna be double QE. Because if this is 1/3 and this is 2/3, it's double, right? So it's just 2 times 3 for BQ. In other words, it is 6. Now, you could also do 2/3 times 9. 9 times 2 is 18, divided by 3 is 6. So you could have done it that way as well. But you also just need to multiply the smaller one times 2. If you're going from the bigger to the smaller, you divide it by 2. All right, this says FC, which is the entire length, is 15. So let's do FQ because that's the smaller one. FQ is 15 divided by 3, which is 5. And that means that QC would be 10 because it's 2 times 5. Or, again, you could do 2/3 times 15. 15 times 2 is 30, divided by 3 is 10. So you could do it that way too. And that's the end of your notes.